As you know, there are four fundamental forces: gravity, electromagnetic, and weak and strong nuclear interaction. In this level of physics, we only deal with gravitational force and those forces that originated from electromagnetic. For example, friction force, normal force, and spring force are all originated microscopically from the electromagnetic, but we're not going to search for the fundamental cause of these forces, but we want to study the different type of forces. Okay, and we have done with gravity, and we have finished a few exercises, and we working on friction, but this week we're going to talk about the friction. Friction forces are due to the roughness between the surfaces. As you can see here, if you zoom into here, you will see that surface is rough and this kind of like teeth bite into each other. And in fact, the friction force is between the surfaces, and that and also it depends on the interaction between the two forces, or the force perpendicular to it. We call it a normal force in this picture. So normal force, and we will make the friction force stronger or weaker. Okay, stronger. The stronger the normal force or the interaction between these two surfaces, the stronger the static friction and the kinetic friction. So it is expressed with this relation here. Static friction and follow this relation. If you have a little bit applied force horizontally, and for example, you're pushing this box, and then the static friction immediately kicks in to against that force. So it's to balance the applied force on this object, and so the object will not moving, okay, or the surface will not slide. And if you have a stronger force and a stronger friction, and stronger applied force and a stronger friction. So if you plot friction versus the applied force, it's going to be along this direction. Now, if you plot the applied force and the static friction, and it will be a linear and diagonal lines straight along this diagonal direction, meaning that if you have stronger applied force, and then you will have a stronger static friction. So they are one on one and in opposite direction, so the object stay stable or at rest until the applied force overcome the maximum static friction the surface can provide. Then the object will start to slide. So, and if you continue apply the force, the object will start moving and accelerating, and there is still friction, but that friction is called a kinetic friction. So basically independent of the force applied. And these two relations summarize the relation between static friction, maximum static friction, and static coefficients and the normal force, and kinetic friction and coefficients of kinetic friction, and then normal force. Simply, they have a linear relation. In other words, you have a stronger normal force, then you will have a stronger friction. Okay. Okay, the force depends on two factors: normal force and the coefficient. But the coefficient is a property between the two surfaces. So it's listed in this table, and if you go online, you just give it the keyword friction coefficients between so and so surfaces. You will have all this number. It is usually a number less than 1, and meaning that the friction is normally just less than the normal force. And so let's work on some problems. Our first example is very straightforward, and exercise friction between surfaces. And also you can click this link to see all the friction coefficients tables. Okay, now calculate the maximum static friction between a block of wood and ice surface. Suppose the normal force is 10 newtons. Okay, that's about 1 kilogram weight. And the static friction coefficient of wood on ice is 0.032. Right, so that's the first question, and that's very straightforward. And then, of course, just simply calculation. Maximum static friction, the coefficients is 0.032. The force is 10 newtons. You multiply out, and the maximum static friction coefficient 0.32. Now, here I had some illustration on this. If you apply a little bit of force, and then the friction immediately kick back, so this object will move, and you get bigger force, big friction, bigger force, bigger friction, until you overcome this maximum static friction, and then the object will start sliding to the left. All right, so that number for this surface is 0.32. Now the second question. What is the maximum static friction if the normal force is 20 newtons? Well, 20, and of course just doubles 20 newtons, and then the friction will be doubled, 0.34, and that's simple math. Frictions. The second question involving kinetic frictions. This is a question out of our textbook. A horizontal force of 95 newtons is applied to a 60 kilogram object. That's the mass on a rough surface. So as a rough, there's a friction. If create accelerated at this rate, 0.2 meter per second, what is the magnitude of force of kinetic friction acting on the force? Think about it. Anything dealing with acceleration or of force. Okay, overall looks like, then let's draw a free body diagram here, and then there's a force applied 95, and then it's accelerate at this 1.2 meter. Therefore, then obviously there will be a friction over here, but the 95 certainly overcome the static friction, and so the object is accelerating the way the applied force wants to. So then let's calculate what is the net force. In other words, the result of the cancellation of the applied force and the static kinetic friction. So acceleration equals net force divided by mass. That's Newton's second law itself. Then we multiply the mass with A, and the net force is 1.2 times 60, and then that's 70 newtons. So the object is moving at this rate is equivalent to a 72 Newton applied force, but not 95 anymore. So where the other part go? And because that's the friction cancels part of it. So this simple equation, net force equal to 95 minus 23 minus friction, and then you do the little math, and then friction is 23. So that's answered the question. So this picture is 95 newtons overcome the 23 kinetic friction, the leftover 72 newtons, and then 70 newtons accelerate the mass at the 1.2 meter per second squared. Now, what is the kinetic friction coefficients between these two surfaces? And so kinetic friction is the friction coefficients is for the kinetic friction. That is when the object and the two surfaces are sliding each other. So the friction is simply mu k, and the friction divided by the mass is 23 divided by 6 times 98. So the normal force and the friction force, that's ratio. This ratio is usually less than 1. So that's the kinetic friction. The friction, that's when object and its touching surface are sliding each other. Question will end the friction chapter. And so 4.26, actually a problem from our textbook. A man exerts a horizontal force of 100 newtons on a crate with mass of 30 kilograms. Okay, so when you read this, you always start your motion diagram or free body diagram. So now let me draw it here. So the crate on the ground. So you apply 120. So now it doesn't move. Okay, if it doesn't move, basically that's a free body. There must be a friction exactly the same amount, but it's in the opposite direction. So friction, static friction, because it not move, it's got 120 Newton exactly, cancels. So, but that's not complete free body diagram. There are another two forces, and namely the gravity is acting on the center. They're going down. Okay, so my pen is sort of in trouble. That way, it's 30 kilograms. So mass times the acceleration, mg, and meter per second. And that gives you a 294 newtons down. Okay, the reason it didn't fall down because there's a floor. So the floor provides a normal force exactly in the opposite direction. That's it. So normal force, you put in my vectors, at exactly 294, but it's upwards. So that's the balance. So the object doesn't move. So that's the. So then, what is the magnitude of the static friction force? A, the answer obviously, since it's not moving, static. Okay, so it's static friction force. It's a vector against the applied force, but it's the same magnitude, 100 newtons. Now, B. So this one actually a bit trickier question, because you think, well, when you want to know the friction coefficients, and then usually it's a measurement depend on what kind of surface it is, either like above ice, and you have ice and wood, glass to glass, and rubber on concrete. If you want information, these are measurements. It's supposed to be given, right? Okay, and that's true. But then here it says, what is the minimum possible value of the coefficients stacked between these? So in this question, is a kind of tricky question, and actually I have to use information from above. Notice that. So the 100 of Newton applied this way, but the friction go this way. So therefore, it says the friction is at least this much. Otherwise, it would have moved. Okay, so we are asked the minimum possible. So therefore, our friction coefficients will be, will be this. So you normally should be the friction over the normal force. Normal force is that. But friction, normal force, the maximum friction, max friction. But now it's not maximum friction because we don't know. So then we talk about the minimum, at least possible value of this. Therefore, think about it. It should be the friction coefficient should be greater than or equal to this force. So because we know 100 newtons is not moving. Otherwise, it's less than that, it would have moved. So therefore, the normal force is 290. Think about it. So at least this much force. So then that is minimum value is this. So therefore, 190 Newton to 290 Newton. So that is, so this is minimum force. Because we see from the above question, because we apply 120, it's not moving. Therefore, friction is at least this much. Could be more likely to be greater than this. So therefore, they ask for minimum value. So now the rest is simply a math. If you press the calculator, it gives you 0.408. In other words, the friction, the static friction is at least, that's why the minimum, at least 40%, 41% of the normal force, because that's why this is current situation, it's not moving. If could be up, what I'm saying, if you apply a little bit more, and maybe still staying. So if you apply 122, for example, and then the friction, it may overcome. So in other words, therefore that's what this means. Minimum possible value of coefficient of static friction is at least 0.4. So the actual one, we don't know exactly what it is, but we know it's bigger than 0.408. Hope this is helpful, and we finish this chapter.